Thank you for those kind words, Stephen. Yes, I'm Jonathan Stevens. I've been working in this field for quite a few years. I actually studied with Peter Molan. That is a name that some of you may remember, at Waikato University as the professor of biochemistry there. And I did my doctorate with him on Manuka and Manuka honey, not really on oils, Manuka oils. Okay, so Stephen has asked me to do a talk on myrtle rust, and I'm happy to do that because I know a bit about it. I don't consider myself to be a world expert on it, but I'm certainly prepared to give you a balanced view. Okay, so off we go. Right, myrtle rust, it is here. Okay, it is here in New Zealand, and it has been reported on Leptospermum scoparium on one plant. As far as I know, one plant in a nursery situation. Okay, so yes, the disease is here, and yes, it does infect Manuka, Leptospermum scoparium. So what I want to do is just run through these points. Okay, I want to talk a little bit about the fungus. I want to talk a little bit about the host and the range of hosts. I want to talk about sensitivity to infection, which is important when you're talking about a rust, and how this particular pathogen behaves and could be expected to behave in New Zealand environment. And all of these points are quite important. All right, I'll try and give you a balanced view of the risk of myrtle rust. So, where did it come from? Well, obviously it's a disease, and it may well be a problem, perhaps not for Leptospermum, but other myrtle species in New Zealand. So we need someone to blame, and it came from Australia, so we can blame Australia happily on that one. And if you have a look, it was first reported in Brazil, 1844, spread to Jamaica, caused some problems in Jamaica, then Florida and Mexico, but the Florida one was the most important one economically, across to California, and from California to Japan, and turned up in Australia in 2010, I think was the first record, and from there has spread to Indonesia, Tasmania, I'm not sure which Pacific island, but some Pacific islands, and turned up here this year. Okay, so it does spread. The spread is actually usually facilitated by humans moving plants around from nurseries, or the cut flower trade is another problem. Even though it is a rust, and rusts disperse easily as spores in the wind, there's a lot of rust species. It seems that this one is long-range dispersal is mostly human facilitated, but I don't think the incursion in New Zealand is human facilitated as far as I know. I think it's probably wind and probably Cyclone Cook and Debbie. Those two events seem to link up quite well with the infection cycle that's occurring at the moment in the Taranaki and in Northland. The incidents in Te Puke that was reported earlier this week looks like an established incident. Okay, so it looks like it's a different infection cycle to the other ones. Okay, so that's on Ramarama. It's in Te Puke. It's a different genus. Right, so let's move on. Right, so can we just think about timelines? Once this rust is in a geographical region of the world, it spreads quickly. Okay, now here's an example in Australia. First detected New South Wales near Sydney, 2010, spread up to the Queensland border by I don't know, 6 months later or something in same year. Central Queensland a couple of years later, in Victoria a year before, finally got to Tasmania on a reasonably large scale a couple of years ago. So all I'm trying to show you there is that once it's in, it will spread. Okay, so I don't know whether MPI will be able to control the rust here in New Zealand. They may eradicate all the sites, so it may become eradicated. But it is in Australia. It's likely to come across the Tasman again in a storm event. And if it is here in New Zealand, it will spread throughout New Zealand. It will spread into the environments that it can survive in. There's a lot of rusts around in the world, plant rusts, and they all produce spores, and those spores are dispersed in the wind readily. Okay, so let's move on. So it does spread. Now let's think about host susceptibility. All right, myrtle rust. The rusts can be quite damaging to plants. They infect leaf tissue mostly, and they kill that tissue in due course. So a plant can die when it's got a heavy rust infection, and they do. But the evidence out of Australia, and they've had 7 years of myrtle rust on myrtle species generally, like eucalypts, etc. You know, there's an awful lot of myrtle species in Australia, say 400 species that are susceptible. The evidence is that there's a range of susceptibilities between different species. So some show no effects at all, some show a little bit of an effect, some will take an infection but it doesn't have any impact, so you'll lose some leaves and that's about it. Some species are highly susceptible and they die, okay, because the rust keeps attacking the leaves keep falling off, the thing can't photosynthesize, and it does just die. So there are different genera exhibit different responses, okay? Now, I said it's been in Australia since 2010, right? There's been quite a few studies of Myrtaceae, myrtle species in Australia, because I mean there's a lot of myrtles there, like I said, and some of them are actually considered iconic species, so there's been quite a bit of work gone into it. And Leptospermum scoparium, there are a range of Leptospermum scoparium garden cultivars in Australia. They are quite popular as garden plants, and a number of these cultivars went into the early resistance screening against myrtle rust trials, okay? And the outcome of that was that myrtle rust will infect Leptospermum, so it is called a susceptible species, but it doesn't kill Leptospermum scoparium, all right? So you've got to understand that it will infect it, but it's not particularly deadly, all right? Now, if you had a young seedling in conditions that were ideal for myrtle rust, so in other words, the environment that you provided the pathogen with is ideal for its growth, it will probably kill a little seedling. But a mature plant, a lot less likely. Okay, I'll just pop back. And it's very important also to remember that, well, let's talk about Manuka here, Leptospermum scoparium, that in New Zealand there's an enormous range of varieties of Leptospermum scoparium within the country, and all of those varieties will exhibit a range of resistance to the disease. So there's a huge spectrum of potential resistance to the disease. The important point so far is, being in Australia for a while, Leptospermum scoparium is exposed. Leptospermum scoparium leaves will take the rust, so it becomes a host, but the rust does not kill Leptospermum scoparium necessarily, unless conditions are such are ideal. All right. Oh, have we missed a slide, dude? All right, sorry. Right, now you know about Purakawa. Metrosideros is the genus. It's an iconic New Zealand species. MPI are worried about its susceptibility to myrtle rust. yes, it may be a problem. I don't have any evidence yet whether it is or isn't a problem, because it's too early days for Metrosideros excelsa, which is Pahudakawa, its exposure to this disease, so time will tell. But here's some evidence about a closely related plant, Metrosideros polymorpha, which is it's a Hawaiian species. It's like a Pahudakawa, but it comes from Hawaii. Now, myrtle rust turned up in Hawaii in, I think, I can't remember, 2012, 2010, 2012, I don't know, some date like that, all right? And people were worried about this plant because it is an iconic Hawaiian species. Obviously, people were worried about it, right? So there's been quite a bit of study gone into it and how and what happened when this species was exposed to myrtle rust. Well, what happened was in nurseries where lots of the seedlings are grown and close together in warm, moist environments which are suited to myrtle rust, you could lose up to 10% of your seedlings in a nursery, all right? So nurseries started to spray fungicides to control myrtle rust in a nursery situation, which works well. The only problem is that the fungicide treatments are not persistent. They last up to about 20 days after leaving the nursery, all right? So in the nursery, because you've got an awful lot of young plant material in warm, moist environment, rust can be a problem, and in this case, up to 10% of loss of plants. Right? That's quite a few, that's a lot. But what happened when the rust was out in the forest, in Hawaii? Well, less than 5% of this species got myrtle rust, was infected by myrtle rust, less than 5%, and of that 5% that did have an incident of myrtle rust on them, less than 5% of the total foliage of that particular bush was actually infected with myrtle rust. So myrtle rust in the forest, even though it's Hawaii, it's moist, etc., it's warm, myrtle rust did not appear to be the problem that had been perceived on this species. All right, and the Metrosideros are thought to be highly susceptible. Generally, okay, so that's a classic example. Now, before I do that last slide there, I need to tell you a little bit about myrtle rust. It's dispersed by a spore. The spore lands on a leaf. The leaf has to be moist. Well, reports contrast a bit, but between 6 and 8 hours, constantly moist for the infection to actually happen. That's the first point. And the second point is that during that entire infection period, the temperature needs to be, I believe, between, according to the literature, 11 to sort of 22 degrees. All right, so the temperature has to be in that range for that entire period. The leaf must remain moist long enough for the little hyphae to grow out of the spore and penetrate the leaf tissue. All right, so it's not like a spore just falls on a leaf on a sunny day and boom, you've got myrtle rust. It's not like that at all. No. All right, now I just want to sum up this part of this presentation just with this. All right, I showed you Australia. It turned up in 2010. It was in Queensland by 2012. It was in Victoria in 2011. Victoria, New South Wales, Queensland, the eastern seaboard of Australia are the big leptospermum honey producing areas, all right? Those are the areas that produce leptospermum honey on a large scale in Australia. Now, So you say, right, well, myrtle rust's been there, and it was widespread, and it was killing some of the susceptible species out in the field. It was there. It was having a big impact on susceptible species, highly susceptible species. What was the effect on the leptospermums in that country, in that area? And that includes Leptospermum scoparium. It is in Australia, in those regions. It's here as well. We like to call it our own, Manuka, but Leptospermum scoparium is in Australia, defined in botanical terms. Now, the effect, even though it has been through all those areas since 5 years, 2012, high levels of infection, the honey crop has not diminished at all right? The myrtle rust has not had an appreciable effect on the Leptospermum species that are harvested for Leptospermum type honeys in Australia. All right, that's my balanced view. Any questions? Because we do have to move on to the next bit. Any questions about all that?
Does it build momentum when it's infected an area, or year to year?
Yeah, the momentum will be built by the amount of spores that you have floating around in the air, but it still requires all of those conditions. I mean, the probability of a spore falling on a leaf in appropriate conditions would increase. No doubt the spore count's pretty low here, and it may have been higher when those cyclones were going through, because like I said, the way things are working through in Taranaki looks like could well have been linked. But if a species is not particularly susceptible to it, I mean, myrtle rust, if it falls on a myrtle leaf, you know, like the whole genus, all the species, and there's all the eucalypts, everything, young foliage in the right conditions will get infected. But if the species isn't particularly susceptible, well, that's it. That leaf's infected and drops off, so be it. The problem is, a highly susceptible species, a leaf gets infected, it goes through its life cycle, which is quite quick on the leaf, and then it produces another batch of spores, and it lands on a whole lot more leaves, and then 2 months later it's produced enough spores on that bush to fully infect all the leaves on it. All the leaves fall off, and the plant's really in trouble. It hasn't occurred on the Leptospermum genus generally in Australia. So yes, Metrosideros might be susceptible. Rama appears to be fairly susceptible. Lophomyrtus, it hasn't been here long enough for me to inform you any more than I have, and that's my balanced opinion. And there is some good literature, by the way. I should have put it on here. Go to the, if you're interested, go to the MPI site, and they've got a lot of stuff on myrtle rust. However, in there, sift through there, and you'll find a very good link to something called NZPPI, which is New Zealand Plant Producers Institute website. And that has a number of very good reports, PDFs that you can download and read. And there's a very good one written by a scientist. Where's Barry? He knows him. It's very full and it's well balanced. Myrtle rust, it may be a problem for some genera. I suspect it's not going to be the problem that has been foreseen for Leptospermum Manuka. Right, I better carry on. Yeah, sure.
Eastern seaboard of Australia obviously has really varied weather conditions.
Yeah.
Some of which are much drier than ours, some might be slightly wetter, but our New Zealand conditions are pretty wet and moist and everything else.
Yeah.
So are our weather conditions more likely to lead to greater susceptibility?
I can't I can't confirm that
Is that
at the
being
moment.
considered at all?
Maybe MPI,
Yeah.
The New Zealand conditions aren't that favourable because we don't get long enough periods of the right temperature often. And you get a considerable slowdown of spore formation throughout the entire winter period, which will considerably knock the infection level back each year. So we'll just have to wait and see on that. I suspect not, but we do see infection developing in Taranaki at the moment. So
And a winter like we're having.
yeah, so
The
let's.
conditions would actually seem quite good.
Yeah, they may well be, but but it's a balancing act between spore density, right conditions on the leaf, and high susceptibility to infection.
Do you know if there's any area in Australia that's more susceptible, that has a greater incidence, like for instance Queensland, northern Queensland?
No, I don't. I'm sorry.
Yeah.
No,
Are they broadcast spraying in Australia?
I don't think so. You'd have to ask Barry. Oh, he's busy. As far as I know, they're not doing any helicopter fungicide work because it hasn't proved to be the problem that it was supposed to be. I mean, initially everyone thought it would wipe out the eucalypt forests. It really hasn't touched the eucalypts at all. I mean, leaves will get infected. Some leaves will get infected, but it doesn't have...
But the rust is susceptible to spray.
Oh yeah, fungicide sprays, and that's what the companies that are producing plants for Manuka farming are taking precautions with fungicide sprays already. Yeah. Barry, was there any widespread fungicide spraying on the eucalypt forests in Australia, or did they just not worry about it? No. Yeah.
I kept recent touch with my old forestry colleagues, and they don't see it.
Right. Okay. I'm sure I've run over time.
All right, no, you've got.
Oh, my time's up. Sorry. Can't do I'll do cultivars. I'll do it quickly. If you're interested in high value cultivars, I'll do them now. All right. High performance cultivars. I've been working with Comvita and various plant breeders for about 10 years on this program, and we've been looking to breed cultivars that perform well, flower well, produce good nectar amounts. And in the wild type Leptospermum scoparium out there throughout New Zealand, there's a huge range of attributes that you can tap into when you're doing selective breeding. So what you do is you select the best in the field in an area that has attributes that you want. You grow seed from them, and then you select the best of that offspring. Then you cross with that against other plants that you brought in from the field. So you're trying to create plants that have elevated characteristics in things like field survival, growth rate, floral density, bee attractiveness or bee visitation, and that's driven often by the sugar content of the nectar, the relative sugar content. And of course we're after the dihydroxyacetone in the nectar because that's what gives the Manuka honey its difference, its activity. Dihydroxyacetone, DHA, converts to methyl glycol, which is what the UMF, non-peroxide activity, is due to. And of course these days we also watch very carefully that our selections have the right amount or more than the right amount of other chemicals such as the MPI marker chemicals. It's no use putting in a plantation of Manuka that doesn't express, say, 3-phenylactic acid, which is one of the key MPI chemical markers, because the honey won't have it in it when it's harvested from that plantation, and therefore it doesn't qualify as a Manuka honey, on the chemical fingerprint. So you have to be in front of the game. You have to make sure that what you're breeding for down the line will express the chemical fingerprint that you need for the honey to be labelled as a Manuka honey, because that's what generates the value. Right, sorry, move on, we better go. Right, so like I said, it's Leptospermum scoparium is a variable species throughout New Zealand. There's a number of varieties that have been characterised. There are varieties that have evolved to fit certain environments, like the Northland one on the Pākehī. On the Gumlands they call it up there. The Pākehī's on the west coast of the South Island. The Gumlands, so you've got waterlogging, drought tolerances. There's definitely a huge range of cold hardiness, and of importance, even more importance now, is disease tolerance. Okay, so there's a spectrum of disease tolerances within these population clusters as well, and that's something that we intend to mine, and I'll come back to that in a bit. But anyway, hold on. Yeah, there's also a suite of garden cultivars, and a lot of them are field hardy, and a lot of them have already got attributes that are beneficial to a breeding program, such as floral density. And if you remember that first slide, just flick back real fast. Yeah. So that's what I call that's what I mean floral density. Okay, that's improved floral density. There's a huge floral load, huge nectar flow on that plant. Anyway, flicking forward. Yeah, done it. Don't worry about it. Okay, that's just a schematic of varieties that can be tapped throughout New Zealand. Our breeding program is New Zealand orientated, and it is non-GMO, so it's just traditional plant crossing. Breed this plant with that plant, get some seeds, grow them, screen them, select the best, so on. You know, just like how all plant types have been domesticated in the world over the last millennia, or 2 or 3 or 4 or 5. Right. Okay, now I just want to give you an example of the sort of things you can do when you're doing selections and breeding plants and reselecting and rebreeding. Okay, so here's a Northland. This is 30 Northland Manuka plants. All right, individual plants spread throughout Northland. And this is the distribution of their dihydroxyacetone in the nectar. It's all normalised, so you're comparing apples with apples with apples, and it's just a direct comparison. Okay, Northland, some are down around 2,000. Very few of that 30 are 10,000. The average is about 6,000 in here. All right. So within that population, there's a spectrum, okay, and the spectrum is centred around there. There's a few very good, a whole bunch of not very good at all, and even more in the middle. Okay, it's a normal distribution. It's what you'd expect to see. Okay, so I'm just getting the idea of distribution into your heads there. Yeah, flick on. Okay, so let's look. Let's look throughout New Zealand. The North Island rather. Wild nectar's 100 odd. Okay, a similar sort of curve. There's a lot that aren't that flash, down around 4,000. There's a reasonable 6, 7 in here, and it tapers down badly. And once you start to get into the good end of the curve, it tapers off badly. Now, when the bees harvest a particular area, and Barry talked about 3 kilometres flying distance from the hive, so just draw a 3 kilometre circle round the hive and think about all the Manuka plants within that 3 kilometre circle, right? So basically a 3 kilometre circle will have a mean value in here, all right? Now, there are different varieties out there throughout the North Island and the South Island, and they do have different mean potentials for honey DHA value going forward, right? So there are some varieties that aren't very good, some varieties are better, and you'll see that on the next graph, all right? But just think about this idea that the bees are averaging all the Manuka nectar in that circle. All right, so now what happens when I start selecting and growing from my selections? Where do I start? And I'm selecting for DHA, so plants that express more DHA in their nectar in relative terms, I'm selecting for them. I start to move my curve, and this whole breeding program is about selecting the best parents, breeding with them, and then selecting the best offspring, and so on and so forth. How much can I move my curve towards the right? Why do I want to move it along here? Because this compound here in the nectar equals UMF in the honey in the long run. So the more of that in the nectar, the more UMF I get out of my honey when it's matured. All right, and that drives the value, and it also drives the medical applications. So it's a good idea to increase this compound in the honeys. Okay, next slide please. So target my selections and my breeding from there. Next slide please. And what is the effect of all that work over the years? Well, here's some nice examples. All these nectars were taken last spring just gone, and we'll start off here. These are different sites within a region, a sub-region of this. Taranaki, here's your DHA. It's all normalized. It's comparing apples with apples. All right, everything's been compared. So Taranaki is not that good. All right, it's not that good. Taranaki. No, the Leptospermum doesn't have a great DHA potential. I mean, there are some specimens that have good DHA potential, and those are the specimens that should be mined for seed for a breeding program going forward. If you're going to concentrate that breeding program on DHA, you've got to watch the other markers too. You don't want to fall off.
You made that comment before. Is there potential that there's less area that doesn't produce these markers, or you talk?
Well, I see a range. In the nectars, so I always watch it to make sure that what we've got is producing enough to meet potential standards going forward. Yeah, I do see a range. Central North Island sites. Yep, Wairarapa is a bit better. That's wild type stuff. The CVT trials, 2014, 2015 nectar trials. Those sites are in the Central North Island, and those nectar collections were done by our Massey collaborators. But there's the sort of mean values that you've got. Right, CVT2, CVT3, CVT4, they're significantly better than all of this, right? So it's a leap forward. Now, the next generation, CVT6 growing in Northland, which is the next generation of cultivars. Northland trial site, do you see pushing the barrow on the DHA? So we're selecting for DHA potential, honey potential, value of honey going forward for culinary, blending into cosmetics, medical uses. And remember what I talked about at the beginning, that we've watched all the other characteristics as we've gone: field hardiness, growth, flowering, more flowers, more nectar, more honey per square metre of ground area. So that's what it's all about. It's trying to enhance the potential crop off a Manuka plantation in the future. And I am watching the Myrtle rust thing. Oh, can I have the next slides? And one of the reasons why I think I'm in a fairly good position to watch the Myrtle rust throughout New Zealand is that's the trial sites in 2010, and that's the trial sites in 2016. Those trial sites have the same cultivars replicated throughout them. So I will know which lines are susceptible or more susceptible. It's important to have a lot of trial sites to be able to. I can breed something and in fact we have bred plants that when we assess them in the glasshouse, they have DHA normalised 25,000 sort of thing, you know, massively high. You look at the result and you think, really, is this right? How would this thing perform in the field? So you've got to roll it out into the different regions. You've got to examine it hard before it can go out for commercial release, because if it falls over, it's just a disaster. All right, so you need the field work. It's absolutely critical.